Hello everyone, welcome to this session. In this session, I am going to explain about the types of fluids. The fluid already we know that fluid is a substance which undergoes a continuous deformation under stress and does not have the definite shape and size. And that fluid, whatever is there, it is of different types. And those different types of the fluids I am going to discuss in this session. Moving to this, the different types. The first one I will take that is ideal fluid. An ideal fluid is one which does not have a viscosity and incompressible. It is an imaginary fluid that doesn't exist in a reality. All the fluids which are in exist are having the at least minimum value of the viscosity. Already we know that viscosity means it's a resistance offered by the one layer of the fluid to the another adjacent layer of the fluid. Then whatever the resistance is there, always there for all the fluids. That's why the fluid which are real exist, all those are real fluids only, not ideal fluid. Ideal fluid and just imaginary fluid. Moving to next one, real fluid. The real fluid having the viscosity are called a real fluids. Example, petrol. All the fluids what are exist in reality are having the viscosity and all are real fluids. Moving to next one, non-Newtonian fluid. Newtonian fluid. A fluid which obeys Newton's law of viscosity, that is, the shear stress is directly proportional to the velocity gradient, that is known as the Newtonian fluid. Example, glycerol in thin motor oil. The glycerol thin motor oil is an Newtonian fluid where the shear stress is directly proportional to the velocity gradient or shear strain. Moving to next one, non-Newtonian fluid. In a fluid which does not obey the Newton's law of viscosity, that is, shear stress is not directly proportional to the velocity gradient, is said to be non-Newtonian fluid. Example, corn flour and water. These are taken as the example. Next one is the ideal plastic fluid. When the shear stress becomes proportional to the velocity gradient and more than yield value, the more than yield value, okay, more than yield value means from more than zero value it will be there where the shear stress is directly proportional to the velocity gradient. That I am going to take next while taking the sketch of that one, expression of this one on the graph. The fluid is said to be ideal plastic fluid. And example will take that is water suspension of clay and fly ash. And that is the ideal plastic fluid. Next one, these are the only the name we have to classify as a incompressible and compressible fluid. And in that first one is the incompressible fluid. When the density of the fluid remains invariant with the application of external force, it is said to be an incompressible fluid. Here, if you apply the force, then density does not changes. Means it will not compress, and that is called as incompressible fluid. And example, what will take all the liquid fluids, example water, oil, etc. All are incompressible only. All are incompressible only, incompressible fluids. And next, moving to another type of fluid, that is a compressible fluid. The compressible fluid, whatever is there, it is when the density of the fluid varies with the application of external force. It is a compressible fluid. Example, all the gaseous fluids like CO2, steam, etc. The steam is also behaves like a gas. All the gaseous fluid which are when by the application of the force will be get compresses and their density will be increases, and those fluids are called as a compressible fluids. Further moving to this one, here the on the graph, the shear stress versus velocity gradient. If you plot all the fluids, this is the ideal fluid. There is no shear stress. The shear stress is zero. That is the ideal fluid. And this is the Newtonian fluid. The shear stress is directly proportional to the velocity gradient. Those are linearly moving. that is the Newtonian fluid. And this non-Newtonian fluid, in this one, shear stress is not directly proportional to the velocity gradient, and that is having the some other relationship between them, and that is called as a non-Newtonian fluid. And ideal plastic fluid, it is a more than yield value it is taken, and where the shear stress is proportional to the velocity gradient. Here, up to this one, it will be behaves like a solid only, and later that will be shear stress is proportional to the velocity gradient. That one more than the yield value. That one, that is called as a ideal plastic fluid, and this is the ideal solid. Ideal solid, and this about the different types of the fluids what I'm going to take here, and this we are going to consider for the explanation of the further fluid mechanics subject. Thank you. Thank you for watching. If you like, share, subscribe, and comment.